Hi and welcome. My name is Katherine Medina Devilers, and I am happy today to teach you about simulations. So, what will we learn today? Well, simulations, we're going to compare simulations with real world contexts. We're going to look at simulations again as abstractions, mimicking real world phenomenon, and using them for studies, making conclusions. Simulations we're going to talk about, they do have bias. They do help us with events that are impractical for experiments. And that's where a lot of our focus is going to be on today. And so here we are, simulations versus an experiment. Simulations is keywords. You're trying to mock a real world abstraction or event. An experiment is you're dealing with the actual real world. You've got the real deal. You're using real equipment. Simulations can be less expensive and, you know, experiments can be more expensive than the simulations. Experiments do provide actual results. Those are actual. That's the real deal. Simulations, they're they provide an estimated results. Um, Simulations, they model those real world events that maybe not are as easy or feasible to have as an experiment. So let's say for an experiment, you may not be able to have the the money or the assets, or it may be actually very dangerous. It's not something you want to do as an experiment. Um, Once it's set up, simulations can be faster. Experiments take a long time to set up. And again, simulations can be safer, even though the results are estimated. Okay, so with no further ado, let's look at a specific simulation. So if we look at a car simulation, we can recap on some of the things we just discussed, looking at a simulation versus an experiment. So simulation for a car, it's safer. Okay, it is going to be less expensive, and you're looking at safety issues that may not previously been thought of. So they do a simulation can bring to light the safety issues without actually having someone in the car and maybe getting hurt. Okay. So again, a simulation would also, it's an easier adjustment to insight on various possibilities, and you can run them faster again than setting up cars, driving them around to do the experiment. So, what are some details you need to maybe eliminate to improve the functionality of a simulation? Well, one of the things you have to understand, a simulation is trying its best to mock the real world event. So, case in point, if you're going to simulate rolling a pair of dice, okay, when you roll a pair of dice in the real world, you're dealing with weight, you're dealing with impracticalities, maybe in a flawed in the design, like one die may weigh a little bit more than the other. You're dealing with the person throwing it, the thrust, the gravity, the momentum. Okay, those are some of the things you're gonna not use in your simulation most likely. Like, let's face it, if you're doing a piece of code to random generate a roll of a die, you're not worried about the gravity or the momentum or the weight of the dice. Okay. Simulations again, and maybe in something like in a medical field or with molecules or with chemicals, it would be safer to do a simulation with maybe some chemicals, especially if they're explosive. Okay. And then you can decide to go ahead and in running your simulation, again, you're going to maybe limit the so-called amount of chemicals that you're using or up it. It's again, depending on how you're mocking your at your environment there. A simulation on flight control, airplane control, that what like some of the things you may eliminate at that time. You may look at one simulation for functionality of perfect weather. You may look at another simulation of slowing things down if it's rainy or it's snowy. So let's look at some examples here. So here, which of the following scenarios is better to do as a simulation than a calculation? So if you can put your video on pause, and we'll catch back up with the correct answer, right? So it's better to do a simulation maybe on the spread of insects on a farm or studying the impact of carbon emissions on the environment. Again, keeping the score at a basketball game or a soccer game, that's an actual number being produced. A simulation is not the best go for that one. And again, determining average grades from a set of quizzes, that's a straight up calculation. That's just taking your quizzes, summing the scores, and dividing by the number of quizzes you have. You don't need a simulation for that. Let's look at now of another example. Example 2. Which of the following statements expresses a constraint of using a computer simulation to imitate a real world object or system? So put the video on pause, read through the choices, and let's catch up. The answer to this one is computer simulations usually make some assumptions about the real world, okay, being modeled. Remember, simulations are biased and they do have those limitations. So let's recap. Simulations are abstractions. We use them with various sets of data. They can be done with the constraints of the real world. They do have bias. They do refine some of our thoughts and ideas and hypotheses and results. Let's look at another example. So we're going to look at a simulation using what would be more beneficial than a calculation again. So we're going to take another try at this one. Put the video on pause and let's catch back up. All right, welcome back. So using a simulation is beneficial on waste of natural rivers, on the impact of maybe the change of the honeybee population. But if you look at A, you're looking at average sales of goods in a particular bakery. That event occurred. You have those numbers. You can just do a straight up calculation. B, keeping track of a high score again of a basketball game. That's a calculation. That's right there. Those numbers are in front of you. So what should you take away? Simulations, we use them to mock real world events or phenomenon. They're abstract. We use a lot of data. They have bias, they have constraints, but in comparison with an experiment, simulations usually are cheaper, they're faster, they're safer. Okay, so they are our go-to when really an experiment is impractical. Okay, and we also, again, let's remember, we do use randomization to help us simulate variability in the real world. So I wanted to say thank you to you. I enjoyed being able to present this topic to you, and I hope to see you again.